Hi everyone, welcome to Integral Calculus. Today we explore lesson 7.4, integration by partial fractions, part 1. Number 1, the idea. We can combine any rational expression such as 2 over x plus 3 over x minus 1. Using LCD, then we have 2 times x minus 1 plus 3 times x over x times x minus 1. And this gives us 5x minus 2 over x squared minus x. This is very useful to evaluate integral such as 5x minus 2 over x squared minus x dx. Such integral cannot be done by view substitution, integration by part, trigonometric substitution. The way to do something like this is we have to be able to do the reverse of LCD, and the reverse is called partial fraction decomposition. Now let's take a look at the partial fraction decomposition. Okay, we have two cases. Case 1, we have a rational expression px over qx, where the degree of px is less than degree of qx. And qx is product of linear factor. Then we can split the fraction out using partial fraction decomposition. Here comes some example. 5x minus 2 over x squared minus x. Yay! As you see up here, yay, you can split this out into some number over x plus another number over x minus 1. A over x plus b over x minus 1. Notice that the degree in the numerator is always smaller than the degree in the denominator. And in case we have a linear factor that is repeated, such as 5x minus 2 over x times x minus 1 square, then this would be a over x plus b over x minus 1, and we need to have another factor of x minus 1 square. So that means c over x minus 1 square. So this is how we decompose 5x minus 2 over x times x minus 1 square. Yeah. Okay, so here come case 2. In case 2, well, we are dealing with the rational expression px over qx, where degree of px is less than degree of qx. Qx is product of factor that contain irreducible quadratic factor. So qx contain irreducible quadratic factor. Similar to the example that we have up here. So here comes an example. Well, we can have something like 3x squared minus 2 over x to the power 3 x squared plus 4. X squared plus 4 is an irreducible quadratic factor. This rational expression, we can decompose it into a over x plus b over x squared plus c over x to the power 3 plus, well, we have x squared plus 4 on the bottom. On the top, the degree must be smaller. So on the top has to be a linear expression. Dx plus e. Yeah. Here comes another example. Let's say we have a 2 over x times x squared plus 4 and then square. So we have an irreducible quadratic factor that has a power of 2. Because similarly to the case of linear factor to the power of 2 or 3, the fraction would be a over x plus bx plus c over x squared plus 4. And then we have another one, dx plus e over x squared plus 4 square. Okay, so far we have considered 2 cases in which the degree of the top is less than the degree of the bottom. So what happens if the degree of the top is equal to or more than the degree of the bottom? If degree of px greater than or equal to degree of qx, then we need to do 2 things here. Then we need to do a long division. To get px over qx into s of x plus the remainder or x over qx. And then we apply the partial fraction decomposition of or x over qx if possible. Yay! Let's take a look at a few examples. Decomposed each. Here comes the first one. 5x minus 2 over x squared minus x. We already know the answer. Let's decompose this one. This is case number 1, because x squared minus x, you can factor the bottom to x times x minus 1. And on the top, we have 5x minus 2. Okay. So what we have is case number 1. And we would have a over x plus b over x minus 1. So now do the LCD. And this would be a times x minus 1 plus bx over x times x minus 1. Right. The denominator is x squared minus x. So the numerator must be the same. We can set 5x minus 2 equal a times x minus 1 plus b times x. And here there are 2 ways that we can solve for this. We can either get a system of equation. That is 5x minus 2 equal to ax minus a plus bx, and get the x together. A plus b x minus a. The coefficient of x must be the same. So phi must be equal to a plus b. And negative 2 must also equal to negative a. Okay. It's the system of equation. From here, we can see very clearly that a equal 2, and then we do the substitution here. Sub equal 2. Then we see that phi equal to 2 plus b. So I mean b equal 3. Another way to solve for this is we just pick a value of x, so we can get rid of either a or b. Pick value of x to solve for a or b. So that is, we can pick x equal to 0. So if we do that, then we can solve a. So we put x equal to 0. Then 5 times 0 minus 2 equal a times 0 minus 1 plus b times 0. Negative 2 is equal to negative a. So a equal 2. Wow. Neat, huh? And then in order to solve for b, well, we can pick x to be 1. Then 5 times 1 minus 2 equal a times 1 minus 1 plus b times 1. This tells us that b equal 3. And this method is very useful for a system that has many variables. b, 2x squared minus 1 over x to the 3 plus 4x. Let's take a look at this one. Factor the bottom into x times x squared plus 4. On the top, we have 2x squared minus 1. We have an irreducible quadratic. So that is case number 2. In case 2, the partial fraction is a over x plus bx plus c over x squared plus 4. Can do a common denominator to get a times x squared plus 4 plus bx plus c times x over x times x squared plus 4. Yay! Now we set 2x squared minus 1 equal to a times x squared plus 4 plus bx plus c times x. So how do we solve for ABC here? We can either set up a system of 3 by 3, or if we don't want to deal with that system, we can let x equal to a number. It is faster to let x equal to some number. Let x equal to, well, we can let it equal to 0. And to get rid of b and c, then we have -1 equal to a times 4. So I mean, a is -1/4. Yay! So we have a. Now we can sub a in to solve for b and c, because there is no way that we can get rid of x squared plus 4. Sub a equal -1/4. Get 2x squared minus 1 equal -1/4 x squared plus 4 plus bx plus c times x. 2x squared minus 1 equal -1/4 x squared minus 1 plus bx squared plus cx. Okay, I get the x squared together. So 2x squared minus 1 and b minus 1/4 x squared plus cx minus 1. There is no extra here, so this is the same as 0. 2x squared plus 0x. Okay, because it is an equation. We get a system here. 2 equal to b minus 1/4. C equal to 0. So I mean, we have C, and then from here we can quickly solve for B. So B is 2 plus 1/4, which is 9/4. And that is it. Once we have A, B, and C, we know the partial fraction of this. Thank you for watching. I hope you found the content useful. Please like and subscribe to help the channel grow. I'll see you in the next video.